Alright, so in this video we're going to be continuing with limits, and we're going to be talking about non-polynomial limits today. Okay, so in the last video we talked about polynomial limits. Today we're going to be asking the question of, well, if we don't have a polynomial, how do we solve that limit? And we're still going to be using our techniques of polynomial limits, as well as our understanding of limits and some of the properties of limits in order to solve the non-polynomial limits. So again, just like we did with polynomial limits, let's just jump into it and see what we get. So we have the limit as x approaches 1 of some function. It's going to be 2x squared minus 1 divided by x plus 1. Okay, and now very obviously this is not a polynomial function, because remember, polynomial functions cannot have a denominator. We can't have fractions, otherwise that's not a polynomial. So we do have a fraction here, so therefore it is a polynomial. So what are we going to do? Well, what we can do, if you remember our rules for polynomials or our properties, we can separate a limit that is being divided, or that is, we have one thing divided by another thing. We can separate that into two limits, a limit in the numerator and a limit in the denominator. So what we're going to do is we're going to say that this is the limit as x approaches 1 of the top part, which is 2x squared minus 1, divided by the limit as x approaches 1 of the bottom part, which is x plus 1. And now remember, when you are doing this splitting of the limit in terms of division, all you have to do is make sure that the bottom part, the denominator, is not equal to 0. Because remember, regardless if we're talking limits, no matter what we're talking about in math, you can never have a 0 in the denominator. So that's the only thing you need to look out for. And in this case, we're good. Okay? And now we know how to solve this. If we look at just this top part, or just the numerator, is this a polynomial? Well, it sure is. And if we look at just the bottom part, is just the bottom part a polynomial? Well, it is. X plus 1 is a polynomial. Do we know how to solve polynomial limits? We sure do. So now we can solve it. And instead of splitting this up into multiple limits like we did in the last video, we're going to use that rule that we talked about at the end of last video that says that we can just evaluate this polynomial at the value that x is approaching. So we're just going to evaluate this, and we're going to get 2 times 1 squared minus 1 divided by 1 plus 1. Everything in brackets is where we substituted in the 1, or where an x should be. Okay, you don't need to write that, but I'm just doing it for clarification. And now we can simply solve this. So 2 times 1 to the exponent 2, well, that's just 1. So that's going to be 2 times 1, which is 2. 2 minus 1 is 1. Divided by 1 plus 1, well, that's just 2. So we get 1/2. Okay? So in this case, we were able to split our function that is not a polynomial into two polynomial limits and solve that way. Okay, let's go on to the next one. This is going to be the limit as x approaches, again, we're going to do 1 of the third root. Okay, so already this is for sure not going to be a polynomial function, but to make it even worse, we're going to have a numerator and a denominator. Okay, so this is most definitely not a polynomial. Okay, and so what can we do with this? Well, again, we're going to use our properties of limits, and we're going to take this third root, or this cube root, and we're going to turn it into an exponent. So now we're going to have the limit as x approaches 1 of 5x over x plus 2 to the exponent 1 over 3. And remember, with exponents, we can take them outside of the limit. So now this is going to be the limit as x approaches 1 of 5x over x plus 2. And the 1 over 3 is going to go outside the limit. Wonderful. And now this looks very familiar to this previous example we had, where we can separate this division of two polynomials into an upper limit or a limit in the numerator and a limit in the denominator. Remember, so long as the limit in the denominator is not going to equal 0, and in this case it won't, we're going to substitute in 1, we're going to get 1 plus 2. That's definitely not 0. Okay, so the limit as x approaches 1 of 5x divided by the limit as x approaches 1 of x plus 2. And then don't forget, all of this is still raised to the exponent 1 over 3. And now we can simply just solve. So we're going to get 5 times 1 divided by 1 plus 2. And all of that raised to the exponent 1 over 3. It's going to get 5 over 3. And if we want to give it as an answer that was the same way that it was given to us, we can change this back into the third root. So our answer for this limit is the third root of 5 over 3. Okay? Let's do one more example here. So we're going to do the limit as x approaches 2 of x minus 2 divided by 2x squared minus 3x minus 2. Okay? Again, this is most definitely not a polynomial, but let's see if we can divide it into an upper limit and a lower limit. Before we do that, we should see if, again, in the denominator, we get a 0. And if we substitute in the 2 here for each x, we're going to get 2 times 2 squared. So that's 2 squared is 4. 2 times 4 is 8. 8 minus 3 times 2, so 8 minus 6. Okay, that's equal to 2. And 2 minus 2 is 0. So in this situation, we can't actually separate our limit into a numerator limit and a denominator limit, because in the denominator we'll have a 0. And again, we're not allowed to have that. So what do? What's our next step? Are we just stuck? Well, no, because what we can do is we can factor. Okay, we can factor this denominator into something. Okay, and if you do the factoring, what you're going to notice is you're going to get 2x plus 1 in one set of brackets, and the other you're going to get x minus 2. And what are you going to be left with in the numerator? Well, you're going to be left with x minus 2. Do we notice something that can be potentially simplified here? We do. We notice that there's an x minus 2 up here, so that's going to go to 1, and an x minus 2 up here, that's going to go to 1. Okay? And you might be asking yourself, well, are we allowed to cancel these out? I thought there was, x minus 2 is still a solution to the denominator. We're not allowed to factor out domain issues. This is true, you're not allowed to factor out domain issues, but remember, this isn't a domain issue because we're not actually letting x equal 2, okay? We're just finding the limit as x approaches 2. We're not trying to find what is this function equal to when x is equal to 2. We're trying to find what is the limit equal to when x approaches 2. They're two different things. The limit means that we're approaching 2. Okay, solving the function at x equals 2 is solving the function at x equals 2. Okay, so they're two different things. We're not actually having any domain issues, and because of that, we are able to factor this out. And because we're able to factor it out, we now get the limit as x approaches 2 of 1 over 2x plus 1. And we ask ourselves, okay, if we substitute 2 here in the denominator, do we get a 0? Well, we don't. We get 2 times 2 plus 1. It's going to be a positive number. We're good. Okay, so now since we have that, we can separate this into a numerator limit. So the limit as x approaches 2 of 1 divided by the limit as x approaches 2 of 2 times 2 plus 1. And that's just going to be equal to 1 over 2 times 2 is 4, and 4 plus 1 is 5. I suppose these limits here actually are not necessary, so this limit isn't necessary. This limit isn't necessary, because now we're actually solving the limits, so we don't need to write limit actually at all. Okay? Wonderful. So our answer is, quite simply, 1 over 5. Okay? So that is some of the ideas and techniques that we will use for solving non-polynomial limits. The first one being using our properties of being able to separate division into a numerator limit and a denominator limit, so long as the denominator is not equal to 0. Okay, and our second one is going to be dealing with any kind of exponents or roots. We can turn them into exponents, take the exponent outside of the limit, and then continue. And then lastly, if we have something where we cannot split a non-polynomial function into a limit in the numerator and a limit in the denominator, we can try factoring, okay? And we're allowed to factor, we're allowed to cancel stuff out, and hopefully once we do that, we'll get some sort of simplification and we'll able to then be separated into an upper limit or a numerator limit and a denominator limit. Okay, in the next video we're going to be continuing with non-polynomial limits, and we're going to be looking at some more techniques that we can use for specific non-polynomial limits and how we can solve those. So that's coming up in the next video.